I don't record this a million times. I pray this is the last take. I pray that this is the last take. Hey guys, how y'all doing on this? How y'all doing on this blessed Sunday night? Y'all good? Okay, that's good. So as promised, I went through a few math test 1 papers and I pulled out common questions that appear. So PEMDAS, that's order of operations, scientific notation, inequalities, and just other stuff that you might see. So that's what you're gonna be doing today. But before we get into that, we get to talk about Pi Day. So yeah. So Pi Day is an annual celebration of the constant pi. So 3.14 and it goes on, right? It is held March 2024, 14th. That's a Thursday. It's held March 14th, that's next month. So if you were on campus that day, or even if you're not on campus, you come on campus, sitting by the T block at 2 p.m., you can purchase pencils, pens, pie, or other sweet treats. So, come out and support the math world, because at the end of the day, you're helping yourself, because all this is being used to better our math world and help yourself, okay? So come out and support. Second thing, y'all had dogs. I can't stop them. I wish I could, but I can't stop them. So if y'all had dogs, just fly that, okay? Let's get into it. So I checked back before I come in to post it because I wanted to post this at 7 o'clock. But a lot of content got damaged in transit and I had to re-edit the content and try put it back into the video. So when you look at the PDF, you might see a lot of questions we didn't do. We might do a question like it, but it ain't the exact same question. That's because I had to hurry up, try edit what I can back into the video so you could have each of everything. So forgive me, and this definitely was a learning experience. So to start it off, you're more than likely gonna see something like this. And the instruction, I forgot an instruction, but only one number is used once. Let me just put that. Sometimes they say that, sometimes they don't, because they might have more than, you might use the same number more than once. But for this one, they say every number used once. I recording, right? Okay, yeah. So let's start off one by one. Let's see, -6 divided by -0.3. You could put this one in the calculator, and you would get 2. And 2, let's see, 2 is a natural number. So these are the counting numbers. So 1, 2, 3, So this could be a natural number or a whole number. But if we put 2 here, then another number we wouldn't be, we'd have to put there 2. And you can't do that because the instruction is every number used once. Y'all can see what I mean. So 2. Okay, and then I would cross it out so you don't get confused. Now this right here means the number repeating. So this would be 0.4444 and just going on, right? So that number would be a rational number. So this includes the integers and all quotients of integers. So Q equals A over B and A and B are integers with baseline equal to 0. So rational numbers can be written in 2 forms. Terminating decimal, so like 0.5, the decimal ends. Or it could be a repeating decimal, so 0.666666, or also all that. The decimal does not end, but it repeats. So this would be a rational number. So we're going to put that -0.4. We're going to cross that out. Put this in the calculator. Like I said, you could put these stuff in the calculator. Pi over 0 is an unreal number because if you put that in the calculator, it should give you math error or something like that. So you could put pi over 0 down here. Cross it out. Now we could solve this. So this would be, we could solve this like, ourselves. So -1 plus 1 is 0. The absolute value of 0 is just 0. Absolute value means like if you have a number in it and it's negative, it comes out positive. So like the absolute value of -5 would be 5, positive 5. The absolute value of 5 would be 5. So absolute value is when you put a negative number, absolute value is when you put a negative number in it. When you put a negative number in it, it comes out, to take it out, it comes out positive. So yeah. So this 0 is a whole number. So if we look, whole numbers, these are the natural numbers plus 0. So natural numbers are counting numbers, start from 1, 2, 3, 4. Whole numbers are the natural numbers plus 0. So see, whole number pi what that was whole number -1 plus 1. This is what I was saying. You could have put the 2 here, but if you did, see, now we wouldn't have nothing to put here, because you can't put this up there because this is not a natural number. This is a whole number. Natural numbers start from 1, so 2 go up here and that stay down there. Okay, cross this out. Anything to the power of 0 is 1, so this would just be equal to -1. -1 is, so -1 would be an integer. Integers are the whole numbers plus the negatives of all natural numbers. So whole numbers plus the negatives of all natural numbers. So -1 here, so integer will be here. And 2 root 5, if you put this in your calculator, 2 root 5, that's 4.47214. That would be an irrational number, because irrational numbers are numbers whose decimal forms are non-terminating and non-repeating. You see, the number can be carried on indefinitely with no repeating digits. So 2 root 5 would be a irrational number. Okay, so reach the fun part. PEMDAS. So all this is just like order of operations. So order of operations says if addition, subtraction, multiplication, and division are written horizontally, do the operations in the following order. So all multiplication and division from left to right, all subtraction and all addition and subtraction from left to right. So we have PEMDAS. So this is the first layer. You do all parentheses and exponents in the equation first. Then the second layer, multiplication and division from left to right. Third layer, addition and subtraction from left to right. So multiplication and division from left to right, right? So we see we have multiplication right here, left to right. So negative times a negative. A negative times a negative is a positive. So this could be 2 plus 2 times all that. Then we have the absolute value sign. So division and multiplication and addition. We doing this first, these two from left to right. So 25 divided by -5 is -5 times 5. And then -1 squared is just 1. We put it on a calculator, -1 times -1 is just 1, so plus 1. And don't forget your absolute value thing. Then over 2 root 5 is 32. So that's root 32 minus 16. So now we can simplify this some more. 2 plus 2, multiplication first. So -5 times 5 is -25. So absolute value -25 plus 1 over -25 plus 1 over, don't forget the absolute value. Don't forget the absolute value. 32 minus 16 is just root 16. So we have 2 plus 2. -25 plus 1 is -24. So that's the absolute value of -24 over the square root of 16 is just 4. Sorry, don't forget that. So 2 plus 2, the absolute value of -24 is 24. So times 24 over 4. And 24 divided by 4 is how much? 24 divided by 4 is 6. So that's 2 plus 2 times 6. So 2 plus 12. So the answer is 14. Not even putting my equal sign or G. Okay, so let's move on to the next question. Okay, so another order of operation question. So, but we have brackets in it. So we have to solve from the inner and go out. So look, when you solving stuff like these, look for the inner brackets. Like you see this one here and then this one here. Because it's just like you adding stuff like, let me see. These inner things is just basically adding stuff and then you doing, okay, so we have the variables like, let's say we have the variables x plus y. So we have the variables x plus y plus z, right? So x plus y plus z, right? You doing stuff to these variables now. So you have x and then plus 2y and then it's just saying you adding these, but you doing stuff to the variables while you adding it. If you all get what I'm saying. So like 3z plus 2y plus 9x plus z x minus 1. So it's like you add in these, right? But in this one you just add in x plus y plus z. But in this one you see you still add in x plus y plus z. But certain stuff happen into these variables before you add them, if y'all catch my drift. So that's what this is. This whole equation is just adding and multiplying stuff, but certain stuff have to happen in certain variables first. So I hope y'all understand what I'm saying. So let's approach this. So like I say, you could just separate the equation. So like separate it if it makes it easier, and just approach it like that. So 2x times 3y is 6y. 6xy, sorry, 2x times 3y is 6xy. 2x times negative 2x times negative x is negative 2x squared. 2x times 1 is plus 2x. And then we have plus 3x. So 3x times 2y is 6xy. So plus 6xy. 3x times negative x is minus 3x squared. 3x times negative 1 is minus 3x. And then we could just say x plus, right? And then put these in brackets because this negative is being multiplied by all that. See all this in brackets. If you see all this in brackets and the negative is being multiplied by that. So before we multiply the negative like that, let's put it in order. So let's put everything in order. So negative 2x squared. We get that from here. We just rearranging it to be in order so we could add it. Minus 3x squared. Minus 3x squared. Let's say plus 6xy plus 6xy. So plus 6xy plus 6xy. Plus 2x plus minus 3x. Plus x. 2 plus x, yeah. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, close bracket. Now we could, oh, don't forget the 3, 5, 3, 5. And then we gotta close this. So 3, 5 minus negative 2x squared minus 3x squared is negative 5x squared. 6xy plus 6xy is 12xy. 2x minus 3x is negative x, and then negative x plus x is 0. 0. And then boom. Now we could multiply the negative by all these, by all this. So we'd have 3, 5, and then this bracket would drop because now we multiplying this 5 to the bracket. The negative, we multiplying the negative through the bracket. So 5, a negative times a negative is a positive, so plus 5x squared minus 12xy, and that's it. So 5 plus 5x squared minus 12xy. So now 3 multiplied by that. So 15 plus 15x squared minus 36xy. And that's our final answer. First thing first, we're gonna convert all these. I'm gonna convert this and this to a scientific notation number. So this would be equal to 5.96 times 10 to the power, now we count 1, 2, 3, 4, 5, 6, 7, 8. 8 times 7 times 10 to the power negative 45 over, put this in scientific notation, so that will be 1.4 times 10 to the power of 1, 2, 3, 4, 5. Now since we go into the right as opposed to the left, that's a negative 5. Now we can reorder the terms. So 7 times 5.96 times 10 to the power 8 times 10 to the power negative 45 over 1.4 times 10 to the power negative 5. So 7 times 5.96 is 41.72. Number, so okay. So 10 to the power 8 times 10 to the power negative 45 is equal to 10 to the power of 10 to the power of 8 plus negative 45, and that's equal to 8 minus 45 is 10 to the power 8 minus 45, that's equal to 10 to the power of negative 37, right? So now we have times 10 to the power of negative 37 over 1.4 times 10 to the power of negative 5. 41.72 divided by 1.4 is 29.8. 10 to the power of negative 37 minus negative 5 is equal to 10 to the power of negative 37 plus 5 equal to 10 to the power of negative 32. So times 10 to the power of negative 32. However, this still in scientific notation, because if you see here, this is 2 numbers on the left side of the decimal place as opposed to 1. 2.98 times 10 times 10 to the power negative 32. Because we take 10 out of this. We take 10 out of this. If you multiply this, these two, it will give you this. So now you have to add this to this. So that will be get more space. Let's just say over here equals to 2.98 times 10 to the power negative 31. Just raising everything to the power 4 now. 3 to the power 4. We'll be working on it in sections. So you see this section being raised to 4, this one being raised to negative 1. So e to the power 4, y to the power 4, x to the power negative 8, because that's 4 times negative 2, and then z to the power of 8. And then times 4 to the power negative 1, x to the power negative 1, y to the power negative 10, z to the power positive 4. The negative times negative is a positive, and 18 z squared y negative 2 x, that's a negative 9. The y thing, I'm just blocking it. Now we're going to reorder the terms. So we can have 3 to the power 4 times 4 to the power negative 1 times y to the power 4 times y to the power a negative 10 times x to the power negative 8 times x to the power negative 1 times z to the power 8 times z to the power 4 over 18 z squared y to the power negative 2 x to the power negative 9. 3 to the power of 4 is 81. We leaving this because we have to put this in the denominator by the negative exponent rule to make the exponent positive. And then that's y to the power of 4 minus 10, that's y to the power negative 6, x to the power negative 9, z to the power 12, over 18, z squared, y to the power negative 2, x to the power negative 9. So we have, now we have to subtract we have to subtract all these variables from the one in the denominator. So we have 81 over 4, because remember I told you the 4 going in the denominator. 4 times the 18 was already there. So now y to the power of 6. So y to the power of 6, y to the power negative 6 minus negative 2 is equal to y to the power negative 6 plus 2 is equal to y to the power negative 4. So that's 81 y to the power of negative 4. And now I could do the rest with my head. So x to the power negative 9 minus negative x to the power negative 9, that'll be x to the power 0. And anything times 0 is 1, so we don't even have to write that. And then z to the power 12 minus 2 is z to the power 10. Now we can simplify this. This is equal to 81 z to the power 10 over 4 times 18 is 72 y to the power 4. And 9 could go into both of them, so 9 divided by 81 is 9. You need no space. Oh gosh. That's 9 z to the power 10. 72 divided by 9 is 8 y to the power 4. So this is our final answer. (2.8) absolute value inequalities. So I can provide my notes in the description, and if y'all want to, y'all can look for 2.8. So this. So let's solve this. So first we have to isolate this. We have to isolate the absolute value. It's supposed to go all the way down. I know why this ain't going all the way down. Isolate. So we have to isolate this. So to do that, we have to divide by this 2 because we have to get rid of this 2. We have to divide both sides by 2. So in doing that, we get 3 minus a half x, 6. Right? So now since it's isolated, we can now say negative 6 less than 3 minus 1 half x, that's less than 6. So we just put the negative of this number here, 6. That's why this have to be isolated, because this have to be by itself, and then we put the negative of this number over here and say that's less than this. Now you have to isolate the x in the middle. So we could subtract by 3 to get rid of this positive 3 in this equation, because if we subtract the whole equation by 3, that would be negative 6 minus 3, 3 minus 3 minus 1 half x, 6 minus 3. So that'd be negative 9, negative half x, 3. See, we got rid of the 3, right? So now we just left with negative a half x. So now we can multiply by negative 2 to get rid of this negative, and then to get rid of this 2. Let me show you. So 2 times negative 9, negative 2, sorry, and negative 2, 1 over 2x, negative 2, 3. When you multiply by a negative multiply by a negative number, the sign switches. So this would be positive 18, and then the sign switches, and this would be x because the negative 2's cancel out, and then this would be it flip because you multiply by a negative number, and negative 6. Now let's rewrite it. Negative 6 is less than x, and x is less than 18. Right? So now we could plot it. We plot the numbers. So negative 6 will be here, negative 18, and positive 18, sorry. Positive 18, yeah. So x is greater than negative 6. So open circle because it's this. If it was this, then it would have been a closed circle like that. And then you go this way. Do I stop this way? Because x is less than 18. So even though x is greater than negative 6, x is less than 18. So we go up here and then we circle. And then we say x here. So this is the final answer here. The graph it too. So for this equation, this LCD, find the LCD. The LCD of 12 and 20 is 60. So you're going to do is going to multiply both sides of the equation. You're going to multiply the whole equation by 60. So this would be 60 5x minus 18 over 12 minus 60 times 3, 60, 120, 180, 180 x plus 2 over 20 equals 180. Now we could simplify it because 60 divided by 12 is 5. That's 5, 5x minus 18 180 divided by 20 is 9. Equals 180. Now you have 25x minus 18 times 5 is 90. Minus 9x minus 18 is equal to 180. Now we got to isolate the x's. So 25x minus 9x is equal to 180. We bring these over. So since we bring it over, it's a positive. So plus 90 and plus 18. So let me show you what you did. You had negative 90 and you added 90. And you have negative 18 and then you add 18. And so whatever you do to the left side, you do to the right side. So we had this, right? And then we wanted to get rid of this on this side. So we added 90 to this side. But now we got to add 90 on this side too. So now you can simplify it. So 25x minus 25x minus 9. So 25 minus 9 is 16x is equal to 180 plus 90 plus 18. 180 plus 90 plus 18 is 288. So we divide by 16, x is equal to 18. And remember we used 60 because that's the lowest common denominator of 12, 20, and 1. So we use 60 because that's the lowest common denominator of 12, 20, and 1. So first we gotta like I say, we gotta isolate this absolute value. So we gotta get rid of this 4 and 3. So we're gonna subtract 4 from both sides. So 4 minus 4, 3, 5 minus x over 2 equals 49 minus 4. We just left with 3, 5 minus x over 2 equals 45. So we're going to divide by 3 to get rid of this 3 over here. So we'd have 5 minus x over 2 is equal to 45 divided by 3 is 15. So now what we do is we say 5 minus x over 2 is equal to 15, and then 5 minus x over 2 is equal to negative 15. So we have the positive 15, and then we have the negative 15. See, this on the negative side. Only this is negative. That's why you get isolate this. Isolate this and get it by itself before we take it out the absolute value. So you're not multiplying 3 by this. That's not what we're doing. You gotta isolate this and then, then we open it up and say 5 minus x over 2 is equal to 15, and then 5 minus x over 2 is equal to negative 15. So now we just solve it individually. We have to multiply the whole equation by 2 to get rid of this. So 10 minus x is equal to 30. Negative x is equal to 30 minus 10. Negative x is equal to 20. Now divide by negative 1. X is equal to negative 20. We divide by negative 1 to get rid of the 1 we're already there. Because one times anything is equal to that number. So we don't write the 1 there. So we have to divide by negative 1 to get rid of this negative on the x. Let's give us the negative 20. So now this side, same thing. So multiply by 2 to get rid of this fraction. So 10 minus x is equal to negative 30. Minus x is equal to negative 30 minus 10. Negative x is equal to negative 40. Divide by negative 1. X is equal to divided by -1. X is equal to positive 40. So like I say, I tried to put each of everything back in. A lot of content got damaged, so I really couldn't do anything about it. I wanted to upload it tonight because I'm not sure, I know test one this week, but I'm not sure which day. It could be tomorrow, Tuesday, Wednesday. But I just want y'all to have, ample time to, look through to try to understand what you could have. So thank you so much for watching. I hope that, this was beneficial to you. I hope that you understand what I did. And if you don't, I got the tutoring link below. You could just book an appointment with anyone in our tutors and we'll assist you with whatever topic you might need assistance with, okay? Don't forget to come out March 14th to support Pi Day. And good luck to everyone on your test ones. Bye!